Systems of equations. Okay. A system of equations is just two or more equations. That's what a system means. So if you have just one equation, there is an infinite amount of solutions. Because I could put 0 in for x and I'd get 1. I could put 1 in and I'd get 3. I could put a half in and I'd get 2. You can put decimals, fractions, negative numbers, positive numbers. You go on forever, right? But if you have two equations, you can get just one individual answer. And what that is the solution, which is what we're doing down here, the solution is where the lines intersect. Okay? So if you graph these two lines, wherever they intersect, that coordinate, that's the solution for this system of equations. So what we're going to be doing is we're going back to we're graphing y equals mx plus b. You got to graph the two lines and find out where they cross. Now eventually we're going to do an easier way where you don't have to graph them. You can find the solution by, well, there's three methods. One really hard one, one easy one, and one so-so one. So, here we have a system of equations. Typically, they write them in standard form. They don't always, but here they are. The x and y are on the same side. So remember, in order to graph them, you have got to get the y by itself. So you just move the 5x over, it changes from positive to negative 5x, and then divide everything by 4. So it'd be y equals negative 5/4 x minus 12 over 4 is 3. This one, we'd move the 3x over, it would change from positive to negative 3x. This would just stay because we didn't move it. Divide everything by negative 4. The negatives would cancel, so this would be 3/4 x. Negative over negative is positive. 20 over 4 is 5. So here they graph the two. This one crosses at negative 3. It's got a slope of negative 5/4. So what they did, instead of going down 5 over 4, they put the negative on the bottom. Remember, you can either have it on the top or the bottom, whichever works best for graphing. So it rises 5, and then it goes left 4. So there's there. This one crosses at positive 5 with a slope of 3/4. So instead of going up 3 and over 4, what they did is they made them both negatives. Because the negatives would cancel, these two are the same thing. So they went down 3 and left 4. And a lot of times they'll do that for these. The point you end up on to draw your lines is the point where they intersect. So that is the solution. So the solution of this system is left 4, up 2. What that means is x is negative 4 and y is 2. You can write it either way. Because when it's written as a coordinate, this means x and this means y. So this is really nothing new that we haven't. It's just that you're going to put two lines on one graph, and then the solution is where they cross. Now, coming up later is sometimes there is no solution. Do you know what will happen to the lines if there is no? They'll be parallel. They'd never intersect. So if you end up having the same slope, there's going to be no solution. And sometimes there's infinitely many solutions, and what that means is when you graph the line, they end up being the same line. They're on top of each other. So that's just the many solution ones. what'll end up happening is these turn out to be exactly the same thing once you simplify them. Okay, so here they did the graphs for us, but just to go through, you got to get the x over there. So it'd be negative 4y equals negative 3x plus 4. Divide by negative 4, and it'd be y equals negative over negative would cancel. Positive 4 over negative 4 is negative 1. So it crosses at negative 1, and then the slope is 3/4. So you rise 3, run 4. And again, when you do the slope, it's going to end up where they cross. So this one, we got to move the x over. So it'd be 2y. This would change to negative x plus 8. And then you just divide everything by 2. So negative x over 2 you'd write as negative 1/2 x. Positive 8 over 2 is positive 4. Everyone know how I got negative 1/2 there? Yeah. When it's just the x here, that means there's a 1 in front of it. So this one crosses at positive 4. And the slope is negative 1/2. So down 1 over 2. So then when they drew that, they intersect right there. So the solution is over 4 up 2. Okay? So you are going to want to be kind of accurate when you're drawing your lines to make sure you know where they cross at. Let's find one that's a little, yeah, here, this one's a little tougher. This one, they already have the y by itself, so this one crosses at 4. So they didn't go all the way up. 1, 2, that'd be right there. And the slope is 3 over 1, so you could go up 3 and over 1, or you could make them both negative, go down 3 and over 1. So to get a straight line, you could just keep doing that. Down 3 over 1, down 3 over 1 to make sure you get a straight line. Then this one, I'd have to move the 7x over. So this would stay negative 3y. This would change to negative 7x minus 6. So divide everything by negative 3. So negative over negative would cancel. Negative over negative would make positive 2. So this one crosses at 2. The slope is 7/3. So instead of going up 7 over 3, you can go back to what it was. Negative 7 over negative 3. So go down 7 and left 3. And that's where they would cross at, right there. So the solution is left 3, down 5. So remember when you're doing, sometimes people get slopes and the coordinates mixed up. Remember a coordinate, you go side to side, the x, and then up and down. On a slope, though, it's the opposite. It's rise over run. It's easy to go too fast and mix those up. So that's all we're doing today.